So, next topic you say limit of functions. First, what is the idea of this? Suppose f is a real valued function. Let f is a real valued function, that is f x when x belongs to R is a, and f x is also real. When we say the limit of this f x when x tends to a some number c, where c is any real number, say R, where the okay. When we say the limit of this is L, the meaning of this is that if this is function f x, I am assuming to be continuous function of course, and this is our c, c, and x is a point which converges to c. Then correspondingly the functional values f of x is tending to L, When x approaches to c, the limiting value of this f x is L. At the point c, the function may or may not be defined. But still the limiting value of this f x, we say it is L. It means the difference between L and f x is very, very small when x is sufficiently close to c. It means that is the f x is close to L when x is sufficiently close to c. That is the meaning of the limiting behavior of the function f x at the point c. At the point c, the function at c, the function f x may or may not be defined. It is not necessarily defined, but what is used, important part is what it is necessary that the point, the necessary part is that f should be defined, at points near to c. Then only limit of the f x has some meaning. If the function is not defined at the point closer to c, then we cannot approach the value of f x when x is approaching to c, because there are so many points where the function is not defined. We cannot find out the f x. So, the important part or necessary part is that in order to get the limit of the function at a point c, the necessary condition is or necessary part is the function must be defined at all points which is very, very close to c. That is the important point. Second point which we get, that at the point c, the function the c may or may not be available in the set A, still we can find the limiting value of f x when x approaches to c. Suppose I say the function f x, say f x is defined over the interval say 0 to 1, and we find the limit of the f x when x tends to 0. So, though the function is not defined at the, the 0 point is not available in the set A, but still this has a meaning, because the function is defined at every point in the interval 0. So, what it says is the point c may or may not be point of A, but even if A the limiting of the f x is possible, we can ignore that point, that whether it is in C or not. What we are interested in, that we will find out the neighborhood of the point A, neighborhood of the 0, this is the 0, we will find the neighborhood of the 0 with a suitable radius delta, and then find the intersection with A. In this, all the point in this set, consider the functional value at this point and take the limit when x approaches to 0. If this limit exists and equal to L, we will say the limit of the function exists. Okay. So, that is one. So, note we can write it note like this. The point C, okay, may or may not be in the point C may or may not be in the set, but still the limit of f x when x tends to C can be defined provided x belongs to the neighborhood of C intersection A. Okay. Function is defined for this. Okay. So, that is the problem. So, before going for this limit, let us see the concept of the crystal point, because always this limiting value that we will consider C as a crystal point for this set. Okay. So, let us see the definition. Cluster point, of a set A. Let A be a non-empty subset of R, a point C, a real number in R, is said to be a cluster point C, said to be a cluster point of A if for every epsilon every delta greater than 0 there exists at least one point x belongs to A, which is different from C, such that mod of x minus C is less than delta. Okay. So, what is the meaning is that a point C is called the crystal point of a set A if for every delta greater than 0 there will exist at least one point x such that x minus C is less than delta where x is. So, this meaning is x minus C mod of this less than delta obviously means that x lies between C minus delta and C plus delta. It means there exists a neighborhood around the point C. It is a neighborhood, this we denoted by B delta C, a neighborhood which is C minus delta C plus delta. Okay. So, a neighborhood can be obtained this in which at least there exists one point x different from C, and this is true always for H delta. Okay. Then we say C is the limit. So, C is the crystal point of the set A if when we picked up the neighborhood of delta, then at least one point x will belongs to this different from C. In other words, you can say a point, or we can also define in terms of the neighborhood a point C is a cluster point. Cluster point is also called the limit point. Okay, is cluster point or maybe the limit point of a set. Cluster point of the set A if every delta neighborhood NBD neighborhood, every delta neighborhood NEIGH neighborhood neighborhood NBD, we will use the word NBD, neighborhood B delta C, that is C minus delta C plus delta, every neighborhood of this of C contains every neighborhood contains at least one point of A distinct from C. Okay. Then we say C is the crystal point of this. Okay. So, basically this is our suppose set A, C will be somewhere here. Now, this will be the crystal point. If we picked up a neighborhood around the P, then there must be a some point x of A different from C available, whatever however small radius you choose. Then we say C is the crystal point. The point C may or may not belongs to A. So, that is the important part is C may or may not belong, may not be a member of A. If it is in the set A, then also we can ignore it. Then even if it is a member of X, it is in A. It is in A, but still we can ignore it. Then still we ignore it while deciding the crystal point, by deciding C as a crystal point. What is more important is that we picked up, we simply picked up whether it is a crystal point or not. Okay. What we see here, we require, that is because we need to show that there is or there be a point, in the delta neighborhood of C intersection A. That is important part, distinct from C, in order for C to be a crystal point. Crystal point of A, that is important. For example, suppose I say A is a set having two element 1, 2, then 1 is not a crystal point. Obviously, 1 is not the crystal point. Why? Crystal point of A, because what we see, if I take the neighborhood of 1 with central set half with radius half and find out the intersection with A, then this set contains only the single point 1. So, there is no other point. So, there does not exist x which is different from 1 in this set, in this collection V 1 by 2 1 intersection A. Hence, 1 cannot be crystal point. Similarly, 2 cannot be crystal point on this. Okay. So, this way we can identify for them. Okay. Now, there is a relation, and we can also define the crystal point in terms of the sequences. So, this result is which connects the concept of the convergence of the sequence and this crystal point. A number C belongs to R is a crystal point of a subset crystal point or limit point, same, okay, limit point of a set, crystal point of a subset A of R, if and only if there exists a sequence A n in capital A such that limit of A n as n tends to infinity is C and A n's are different from C for all n belongs to capital N set of natural number. So, that is the important part is. Okay. Proof of this is, it means if C is a crystal point of a subset A of R, then there will be a sequence available in A. If this is our C and here is A, so there will be a sequence x1 or A1 A2 n, A1 A2 n and so on, which will converge to C, which will go to C, but n's will be different from C. That is, if I draw a neighborhood around the point C, then you will get the n's different from C. For any neighborhood, we will get at least one n's available in this. So, let us see the proof. If C is a crystal point of A, then by definition, if it is then by any delta neighborhood of C must includes the some point which is different from C. So, delta I am choosing to be n, then for 1 by n, then for any n belongs to n, the 1 by n delta neighborhood of C, the 1 by n neighborhood of C, delta becomes 1 by n, contains at least one point A n which is distinct in A n in A, distinct from C. This is by definition of the crystal point. So, what we get? Then we get A n's, these are in A n's are different from C, and the distance of A n minus C is less than 1 by n, and this is true for each n. There will be some A n's. So, this implies the limit of A n as n tends to infinity is C. Okay. Conversely, if suppose the limit of A n is given to be C, given that limit of A n's as n tends to infinity is C, means there exists sequence A n such that limit is n. Okay. So, conversely, given a sequence A n, in the set A minus this C, such that limit of this A n is C. This is given. So, by definition of the limit, then for any delta greater than 0, there exists a k, a positive integer k, such that if n is greater than or equal to k, then A n's will belongs to the neighborhood of C with delta neighborhood of C. That is by definition of this. Okay. For any delta, we can find out this. There, after certain stage, all the terms of the sequence will belongs to this delta neighborhood C. Therefore, delta neighborhood, the V delta C, delta neighborhood of C contains the point n's for all n greater than C and different from which belongs to A and distinct from C, distinct from C. So, this implies that C is the cluster point of A, is it not? So, C is the cluster point of A. That's one. It means we can, in terms of the sequence also, we can define the cluster point, okay, in neighborhood or cluster. Now, let us see few example. Suppose x I take open interval or A with the open interval 0 1, which is subset of R. Okay, R. Now, this is a complete interval 0 to 1. Every point will be the cluster point. Why? Because when you take any point here, C, any point of this, say I take C here, then one can identify any neighborhood around the point delta neighborhood if I choose. Then one can identify the points of the set which is distinct from C. So, C becomes the cluster point. So, and this is true for any C is arbitrary in between 0 1. So, every point in the this is a cluster point, as well as, so every point including 0 and 1 are cluster point. 0 1 is also cluster point for this cluster point, but neither 0 and 1 both are not available in A. So, similarly, closed interval 0 1 we can choose like this, say finite set of real numbers. Then finite set of real number means, suppose A 1, A 2, A n, these are the sets, elements of the set, but it does not fit at any limit point, has no cluster point. Why cluster point? Because if suppose some point is a cluster point, say any point whether in between or outside. If suppose say A 2 is the cluster point, then there is a gap between A 2 and A 1, A 2 and A 3. So, if you draw a neighborhood around the point A 2, you will not get a point other than A 2 inside this. Basically, no point will be available. So, it cannot be a cluster point. If a point is outside of this set, again there is a gap between A n and this, and we cannot get the a point in the neighborhood delta which is distinct from this. Okay. So, point of the set. So, this is not a cluster. So, finite set does not have a limit point, no cluster point. Similarly, infinite set capital N of natural number has no cluster point. The same reason is the same, because this is our natural number 1, 2, 3 and so on. Now, we cannot take we cannot get any neighborhood around the point which contains the point other of the set other than that point. Suppose I take 1 and I say 1 is the cluster point, say, then if I draw a neighborhood like this, now this neighborhood does not contain a point of the set other than 1, because basically no point is available. So, 1 cannot be a cluster point. Similarly, 2, 3 are. So, this infinite set and has no cluster point. Then fourth example, the set A n, if I take the set 1 by n, where n is a natural number. Now, this has 0 as a cluster point. Why? Because this is our 0, here is 1, then half, 1/3 and like this. So, the sequence is decreasing, okay, decreasing, and it clustered around the point 0, means if I draw any neighborhood around the point 0, there are so many points will be available here after a certain stage which are close to 0 and different from 0. So, 0 becomes the cluster point for it. Then if we take the I, an interval closed interval 0 1, and consider a set A which is I cross intersection Q. Q is the set of rational numbers. It means the interval 0 1 is chosen, and then from there you are finding the intersection with Q. So, A is the set of all rational numbers lying in between 0 1, this closed set 0 1. Okay. Then every point in I is a cluster point of A phi. Then every point I, then became, then every point of I is the cluster point of this set A. Every point in I or I is a cluster point of this. Why? This is because of the result which we have seen, that between any two rational number there are always a rational number. Infinite rational number can be finite in between the two rational number. So, if I picked up any point here, say 0, then draw the neighborhood. Now, since between 0 and 1 rational numbers are dense, this is the reason is because rationals are dense in real. Closure of rational number is the entire real line. Okay. So, once it is rational dense, so if you picked up any number, you will always get in vicinity another rational number, and which is distinct from that number. So, every point of 0 1 becomes the closed cluster point for this set A. Okay. So, that is one. Now, we come to the concept of the functions. Crystal. Now, this important part, definition of limit. Let A or limit of the function that is important. Let A be a subset of non-empty subset of R, and let C be a cluster point of A. For a function f, which is a function from A to R, a real number capital L is said to be a limit of the function limit of f said to be a limit of f at C if given any epsilon greater than 0 there exists a delta which depends on epsilon, of course, delta depends on and positive. There exists a delta greater than 0 such that if x belongs to A and 0 less than mod x less c less than delta, then mod of f x minus L is less than epsilon. That is what is okay. So, what is the meaning of this is that this is our C is the cluster point, C is the cluster point of a set. Suppose this is the set A, okay, and C is a cluster point for this set A. A function f is defined from A to R. So, this is our function f which is defined carrying A to R. This is R, suppose here everywhere the function is defined. So, we get this is f x range of this. So, what he says is that if we say that L, this L is the limit of the function f x at the point C, that is if I take x and x tends to C, the corresponding function f x, this goes to L, limit of f x is L, means that if we take any epsilon greater than 0, then there exists a delta such that this for all x belongs to this, and f x minus L is less than epsilon. So, if I take a epsilon neighborhood around the point L, that is here f x minus epsilon, f x plus epsilon. If we choose this, that is, this is our f x minus epsilon, f x plus epsilon. Here is C, C minus delta, C plus delta. So, for the given epsilon greater than 0, for the given epsilon greater than 0, there exists a delta such that whenever we take any point x different from C in this neighborhood, the image of this will fall within this range, within the L minus epsilon to L plus, sorry, this is L minus epsilon, L plus epsilon and L minus epsilon. This will be, sorry, will fall within this range. Then we say that this limit of the f x is L. Okay. Thank you very much. Thanks.